Good morning friends. Welcome to Parnika Tutorials YouTube channel. In the last video, I have discussed about the closer operation and goto operation. I hope you have watched that video. If you did not watch that video, I request you to go back and watch that video and come back to this video for better understanding. In this video, I want to discuss one of the LR parser, which is LR0 parser. LR0 parser is a bottom-up parser. So, to do the LR0 parser, we need the LR0 parsing table. Am I right or wrong? Okay, so what we have to do? We will have a stack which consists of the bottom of the symbol, which is dollar, and we will have the input buffer. Okay, and we will have the LR0 parser, and then we have to give the LR0 parsing table. So for the LR0 parser, okay, I need to give the LR0 parsing table and also the input string in the input buffer, and with the help of the stack data structure, it will construct the parsing tree. So the final objective of any parser is to construct the parsing tree. So I will take one grammar. First I will discuss about how to construct the parsing table. To construct the LR0 parsing table, we need to find the LR0 items. Okay, is it clear? So from a given grammar, first we will find out LR0 items. From the LR0 items, I will construct the parsing tree, and then I will take one string which can be generated from the given grammar. That string I will store it in the input buffer, and the parsing table and the input buffer I will give to the parser. With the help of the stack data structure, it will construct the parsing tree. So entire process I will discuss in this video. So I request everyone to watch the complete video for better understanding. Now let me take one grammar, and then we will do the entire process. Okay, so let me take a grammar called S determines AB, A determines A, B determines B. Is it clear? Now can you tell me what are the non-terminals in this grammar? The non-terminals are S, A and B. What are the terminals? The terminals are small a and small b. Will you agree with me? Now, first thing what we have to do is that we need to construct the LR0 items. Let me discuss how to construct the LR0 items. To construct the LR0 items, you should know about the closer operation and goto operation. So one thing we will do is that we will take the extra production such as S dash dot S. Is it clear? Means we are taking an extra production for the given grammar. In this grammar we have only 3 production. So to construct the LR0 items, I have taken a extra production, which is saying that I have taken a one dummy start state. From the dummy start state I am going to the start state. From this one, if you look at it, if I add this production, what are the strings previously this grammar is generating? After adding this production also it will generate, because I am just adding like that. S dash determines dot S. Now for this one I need to compute the closer. Okay, so for this one I need to compute the closer. What is the closer? Whatever this one S dash determines dot S, okay, that will be added, and S determines dot AB, then A determines dot A. Am I right or wrong? Is it clear? So this is the item 0. Let me name it as I0. So we have completed the closer of S dash determines dot S. What is the meaning of this dot? We need to perform the shift operation over this S. It means after dot whatever it is there, over that one we need to perform the shift operation. Suppose if it is, let's take that A determines A dot, means after the entire symbols in the right hand side, if you have a dot, then meaning is that you have performed the reduction. Meaning is that entire string you have parsed and you need to just perform the reduction. Means the reduction is happened. Suppose if it is A determines A dot B. Now you need to perform shift over B. That is the meaning. Is it clear? The dot represents whether you need to perform the shift operation or you need to perform the reduction operation. Now I want to perform the go to operation. So go to, it is like go to I naught on S. Am I right? So on S, first what we have to do, we have to shift the dot. Am I right or wrong? This is what the go to operation. After that, if it is required, we need to compute the closure. Now no need to compute the closure for it one. So I will complete this item and I will write it as I1. Okay, why I am naming them, you will understand when I am constructing the table. Now you have a dot here. Again you need to compute go to I0 on A. Is it clear? So I0 on A is S determines A dot B. See, whenever you are computing the go to, first thing is that you need to shift the dot. Previously dot was before A, now it will be after A. Now what I need to do? I need to compute the closure. So what is the closure I need to find? Before B I have a dot, so I need to look at the grammar and I need to find the productions over B. So it is B determines small b, that you please write it. Okay, so we have computed the closure which is I2. Okay, now on small a, go to I0 on small a, which will be A determines A dot. Is it clear? Are you able to understand? So this is completed because this is completely reduced. This is also completed. Let me write it down as I3. And now this on B, let me see. So this is what? Go to I2 on B. Whatever it is happening, we will see. First thing is that what I have to do? S determines AB dot. Am I right or wrong? Anything else it should come? No, it will not come anything. So let me name it as I4. Okay. And now I need to compute go to I2 on B. See, whatever the dots are there, dot B is there. So you will perform the go to operation on B. Again dot on terminal B is there. Again we will compute on B. So B determines B dot. Now this is I5. Now if you look at it, this one is completed because it is completely reduced, and this is also completely reduced because finally you have the dot. This is also completed, this is also completed, this is also completed. So we have completed the computing the LR0 items. The items are I0, I1, I2, I3, I4 and I5. I hope you have understood how I computed the LR0 items for this grammar. Let me discuss again. First thing what I have done, I have taken an extra production called as S dash determines S. For that one, I need to compute the closure, so I have added the dot. So S dash determines dot S. Now I need to compute the closure. How I will compute the closure? Because after dot S is there, so you need to check the productions from the given grammar. What are the production is there? S determines AB is there. For the before AB you need to add a dot. Now the closure is not completed because after dot there is a non-terminal. Again you look at the production, A determines A is there, so you add a dot. Now after dot this is a terminal, so we have completed the closure operation. Is it clear? Whenever dot after that non-terminal is there, then only you will start the closure operation. Whenever after dot a terminal is there, we have stopped, because for this A we don't have any production because it is a terminal, it is not a non-terminal. So then on S I have computed the go to, I got the I1. On A I have computed the go to, I got the I2. Here I have performed the closure operation. On small a, I have got the I3. From I2 on capital B, I got the I4. On B, I got the I5. So we have completed the construction of LR0 items for this grammar. Now next step is what? We need to compute the LR0 parsing table. Okay, LR0 parsing table, if I want to do it, let me name this production. This is the production number 1, this is the production number 2, this is the production number 3. So for constructing the LR0 parsing table, the step 1 is that I need to name these productions. This is the production number 1, production number 2, production number 3. Is it clear? Why they will be useful, you will understand now. So let me construct the LR0 parsing table. Okay, so you will have items. Okay, you will have the items, you will have action part, you will have the go to part. Okay, let me name them. Okay, is it clear? What is the action part consists of? The action part consists of terminals and the dollar. So what are the terminals are there? Small a, comma small b, and add u dollar. Is it clear? Are you able to understand it or not? Okay, what is the go to part consists of? Non-terminals. What are the non-terminals? Yes, a and b are the non-terminals. Okay, now how many items we got? I0, I1, I2, I3, I4, I5. List out them. You have I0, you have I1, you have I2, you have I3, you have I4, and you have I5. Okay, so totally you got 6 items. So 3 plus 3, it is completely 6. Okay. Now, you may get the doubt that, sir, why you added this extra production s dash determines dot s. Now, when I'm constructing the table, you will understand why we have added is that the parser should stop somewhere. Am I right or wrong? Because the parser is an algorithm. So, that algorithm you should have a end step. Am I right? Otherwise, if it goes infinity, we cannot do anything. So, if it should end somewhere, this production will be useful for us to know when the parser will end its procedure. Okay, that you will understand when I am discussing about the table. Okay, so now let me take the I0. I0 on non-terminal S, where you have gone. You have gone to the I1. So, please note down this point. I0 on S, where S is a non-terminal. If it is a non-terminal, we will write it in the go to part. If it is a terminal, we will write it in the action part. Okay, so I0 on non-terminal S, you have gone for the I1. So you write here as 1. Okay, you need to write the 1 here. So I0 on S, you went to the I1. That is the meaning. Now I0 on A, where A is a non-terminal, where you went I2. So you need to write it as 2. Is it clear? Are you able to understand? Now similarly I0 on A, where you went I3, where A is what? Is a terminal. So if it is a terminal, you will write it in the action part as S3. Is it clear? So you need to perform shift 3. See, whenever you are writing it in the action part, you will have only shift operations and reduce operation, and then you have the accept. Whereas in the go to part, you will have the numbers as 1, 2, 3, so on. Is it clear? So we have finished with the I0. Yes, A on small a, done. Now come to the I1. I1 is a reduced move. Now if it is a reduced move, as it is an augmented production, we will write the accept state in its dollar. Is it clear? Please note down again. I1 is a reduced one. Is it clear? If it is reduced, what is the meaning? You have completed the dot operation over this S. Is it clear? So, as it is a reduced move and it is not the production in the original grammar, so it is an augmented production. So, we will write the accept. So, that is what I told you. When the parser should stop the process, will be will be informed by this augmented production. So whenever the parser reach this accept state, then the parser will stop its process. Now come to the I1 is completed. Come to I2. I2 on B, you went to I4, where B is a non-terminal. I2 on B, you went to I4. So let me write it as 4. I hope it is clear, visible for you. I2 on small b, you went to I5, where B is what? Is a terminal. If it is a terminal, we will write it in the action part as it is I5, I will write it as S5. I2 on B, we will write it as S5. So I2 is completed. Okay. Now come to I3. I3 is a reduced one. Is it clear? If it is reduced, you need to look at the production. The production number is 2. So it is a reduced one. So we will write the R2. Why I am writing R2? It is reduced and the production number is 2. So that's why I am writing as R2, and I will write the R2 in the entire action part. Means in all the terminals A, B and dollar, I will write the reduced move R2, R2, R2. Is it clear? I hope it is clear for you. Come to the I4. I4 is also reduced. How I came to know that it is reduced? Because the entire one right hand side symbols are finished, then you have the dot. So I can say that it is reduced. So you look at the what is the production number? 1. Production number 1. So in I4, you need to write the R1, R1, R1 in the entire action part. Please note down this point. Now come to the I5. I5 is a reduced one. And what is the production number? Is 3. So you need to write R3, R3, R3. So we are done with the LR0 parsing table construction. Is it clear? So what I have done, I have listed out all the items from the LR0 items. Then I have written the action part. The action part consists of all the terminals and also the dollar. And you will have the go-to part consists of all the non-terminals. By looking at the LR0 items, we will fill this LR0 parsing table. Now what is the next step? We need to take a string which can be generated from this grammar, and then using the parsing algorithm, means LR0 parsing algorithm, we need to construct the parsing tree. Is it clear? So what is the need of this LR0 items is completed. So that I will erase this one. This space I will use it for explaining the LR0 parsing algorithm. Okay, is it clear? So now let me take a string as AB. Okay, now we will check whether AB can be generated from this grammar or not. If it is generated, what is the parse tree? Now whenever we are using any parser, the string should be end with dollar, so that we will understand that the string is finished. Okay. Now let me discuss about the parsing process. Okay. Now we will take a stack. Okay. We will take the input buffer. Okay. Your input string, and then we will write the what is the action we are performing. These are the 3 things we will take. One is the stack, and another one is the input, and what is the action we are performing. Now your input is AB dollar, and initially the stack will consist of dollar. Okay, and also because the stack is now empty, now you will take the item number I0, because from I0 you are starting. So we will write it here it as 0. Are you able to understand why I am writing 0 is that your table is started from I naught, so you will write 0 here. Now listen this procedure. Look at the I naught, because this 0 is nothing but I naught. I naught and your input pointer is pointing to the A. This is very important. So I naught on A, what is happening? Shift 3. Is it clear? S3 means shift 3 you need to perform. So if you want to perform the shift operation, meaning is that you push the, what is the terminal the input pointer is pointing. Here the input pointer is pointing to a terminal called A, that you push it into the stack. So initially you have a 0. If you push the A, it will be A, and also you need to push this number S3, shift 3. So you write 3 here. Is it clear? The S3 meaning is that first perform the shift, shift means push this A into the stack, and as it is a 3, you push the number 3, meaning is that you are pushing the I3 there. Is it clear? Are you able to understand? Now tell me, what is your input is consists of? Your input consists of B and dollar. Now where your input pointer is pointing to the B. Is it clear? Are you able to understand it or not? Now look at the 3 and B. 3 and B is written as R2, because on 3, on B it is R2. R2 means reduce move R2. What is that one? A determines A. So in parallel, let me construct the parsing table in parsing T also. You have AB. I hope it is visible for you. Okay, I have taken AB. Now your input pointer is pointing to this one. Now A determines A is there. Now look at the first thing. The first thing you need to look at is, whenever you have a reduced one, you first write the production. A determines A. Now look at the production and count how many symbols are there in the right hand side of the production. Now if you look at it, we have only one symbol which is there in the right hand side of this production. Now 1 into 2. How many number of string, means how many alphabets are there in the right hand side, into 2, those many number you need to pop from the stack. Let me repeat again. The number of symbols in this production in the right hand side is 1. So 1 into 2. So first 2 symbols we need to pop it from the stack. Okay. So if I pop 2 symbols from the stack, what are they we have to pop? We have to pop 3. Then we have to pop the A. So I have popped it. And whatever the symbol which is there in the left hand side of the production, we need to write here. Is it clear? A lot of students will confuse this procedure. So what you have to do, you need to count the number of symbols in the right hand side into 2. Those many symbols you need to pop it from the stack, and whatever the symbol which is there in the left hand side, that symbol you need to push it into the stack. Now what is the meaning in the parsing tree? Now as your input point is pointing to this one, but it will do the reduction A on A. This is what it will do. Meaning is that from A you have reduced it to A. Is it clear? Even that's why it is called as LR0. Are you able to understand? Your input pointer is pointing, but you are reducing the previous one. Is it clear? Okay. Now remember another step. 0 on A. 0 on A, you look at it. 0 on A, it is written 2. So you push the 2. So what operation we have performed here? Reduce 2. Means reduce production number 2. Let me repeat again here. I naught on A. I naught on A is 2. So we have pushed the 2. Now what is your input pointer is pointing? Still it is pointing to the B, and you have the dollar. Okay. Now look at it. 2 on B, where it is? In 2 on B, it is written as S5. So write the operation called shift 5. What is the meaning of shift 5? First you need to push the B into the stack. Okay. push that B into the stack, and then as it is 5, shift 5, you need to push the I5 also into the stack. Now what is your input pointer is pointing to the dollar. Is it clear? Are you able to understand? So shift 5 means you need to push this B and also 5 into the stack, and you need to shift the input pointer. That is what you are shifting towards this side. So you have the dollar. Okay. Now look at it. What is your input pointer is pointing? Your input pointer is pointing to the dollar. So here the parsing tree, it is pointing to the dollar. Means even the dollar is not there, but consider that you have a dollar and it is pointing. Is it clear? Now listen carefully. 5 on dollar, what it is there? 5 means what? I5. I5 on dollar is R3. Okay. R3 means reduce 3. Okay. Now if it is reduce 3, what is the 3? Production number 3 here it is B determines B. B determines small b. So first thing what I need to do, I need to count the number of symbols in the right hand side. The number of symbols in the right hand side is 1. So 1 into 2, which is equal to 2. So the two symbols from the stack need to be popped. What are the two symbols? Obviously, whenever we are doing the stack operation, it is lost in first out. Okay, so 5 and B will be popped from the stack, and you will have 0, A, 2. And then what you will do? Whatever the symbol which is there in the left hand side of the production, that symbol we need to push it into the stack. Is it clear? And you have the dollar here still. And remember one thing. Once we pushed this left symbol in the stack, you need to look at I2 on B. I2 on B, you have a 4. Okay. Now you can ask me one doubt, sir. In this table, whenever you are looking I2 on B, there is some value. If there is no value, let's take that I2 on A I am searching. There is a chance is there. Am I right? I have taken this string. For this string, I am not getting the situation. But I2 on A I am looking. It is an empty. What is meant by empty? Undefined one. Undefined one, we will call them as errors. The same way how we have called them in LR1, not LR1, LL1 parsing, which is predictive parsing. So these empty boxes are the errors, which are undefined one. Okay. What is the meaning? Suppose let's take that I2 on B, you got the error. Meaning is that whenever you are computing this parser, whenever we get a error, the meaning is that the given string cannot be generated from the given grammar. Is it clear? Are you able to understand? So the errors will tell whether you can derive the string or not. Now where we have stopped? Okay, we have stopped 4 on dollar. We need to look because I2 on B we have looked 4 and we have pushed it into the stack. Now 4 is the top of the stack and the input pointer is pointing to the dollar. 4 on dollar, it is R1. So you need to perform the reduce R1. R1 means production number 1. So first write the production number 1 as S determines AB. This is your production number 1. Now count the, I hope it is looking like a B. Now count the number of symbols in the right hand side. You have 2 symbols in the right hand side. So 2 into 2 is equal to 4. So 4 symbols, you need to pop it from the stack. So the 4 symbols are, these are the 4 symbols. Okay. So let me write here, reduce 1. Okay. Now 4 symbols I have popped, I got the 0. Now what is the next thing you need to do? You need to look at the symbol which is there in the left hand side of the production and push it onto the stack. Okay. Now what is the next thing you need to do? You need to look at I0 on S. It is 1. Is it clear? I0 on S is 1. Okay, and still your input pointer is pointing to the dollar only. Is it clear? So I forgot to write this parsing tree. Now look at it where we have performed the reduction. We have performed the reduction, we have written here. We have performed the reduction 3. So reduction 3 means R3. Because you are pointing to the dollar, R3 means what? B on B. So from this B, you will reduce to B. Okay, then you have reduction 1. AB R1 is nothing but the production 1. From AB you are getting the S start symbol. So we have completed the parsing tree. Now look at the parsing process, how it will be. Because once this parsing process complete, then only we will say that the parsing tree is completed. But as we are a little bit anxious, then we said that as we got the start symbol, we said that parsing tree is completed, because as it is a bottom up parser, we will take the input string or the terminals, and then we will try to go to the start symbol. Now look at how the parser will end. Now look at it. 1 on dollar, I1 on dollar is what it is written, accept. So it is accepted. So once we reach the accept, then we can stop this LR0 parsing process, and I can say that we got the parsing tree. So I hope we have understood from the given grammar how I have identified the non-terminals and terminals, and how I got the LR0 items. From LR0 items, how I got the LR0 parsing table. From the parsing table, how I got the parser. From the parser, how I got the parsing tree. I hope you have watched the entire video and you have understood the concept clearly. If you still have any doubts, don't worry. I will discuss in the next video few examples, and even I will discuss about SR conflict, RR conflict, which are possible in LR0 parser. Thank you for watching my video. Have a nice day.